So here we are in part two. Hopefully you found the area of this rectangle. And this is what I'm talking about. You know, we're doing something a little more involved here in terms of finding the area here. You know, you do have the base on this one. 8's the base. You don't have the height. A little Pythagorean theorem allows you to find that height. You'll notice the height is a little smaller than the base. So if you do 8 squared plus 8 squared equals 10 squared. Should end up with 6. So 6 times 8 is 48. And I'll emphasize putting units on here. It's 48 feet. No, it's 48 feet squared. 48 square feet. Make sure you're careful with units when you're asked about area. Second formula on here is for parallelograms. And it is the exact same formula as it is for a rectangle. Important to note that. But again, we've got to be careful. We're not doing base times this side length over here. It's base times the actual height. So depending on where you draw this height, you can draw it anywhere along here. If you draw it right there, you can see why this formula is the same as that formula. If I use scissors and just chop that off, I could cut that triangle out and move it over here and fill in this gap that's right here, and you'd have a rectangle. You know, that space, that two-dimensional space, the square units here would fill that in. That's why that formula works the way it does. And again, that's why we're using this altitude instead of this side length here. Side length is sort of irrelevant. The height is what's relevant. Hopefully that makes sense. There's your base, there's your height, and why those formulas are the same. So I'll give you an example again. In the middle of the page, try that one. Got a 37-degree angle. Bottom side is 24, the right side is 10. Pause this thing, give it a try, see if you get the correct area. So hopefully you drew an altitude somewhere in there. I would argue the nicest place to draw the altitude is chop off this little triangle on the left-hand side where the 37 is. Don't have to draw it there. You could draw it on this side, because if that's 37, that's also 37. You could do it that way as well. Parallelograms, you know that this is 10. This diagonal here is also 10. That slant over there is also 10, which, you know, you maybe ignore the 24 for a moment, and you've got a little right triangle here with 10 hypotenuse and 37. And all you're trying to find is the height, because you have the base. So if you do a little sine ratio, sine of 37 is h, my height, over 10. So I'll multiply the sine of 37, where their decimal is times 10. I think you should get around 6 for the height. And then simple, 6 times 24, sorry, 6.02, and all those decimals times 24. Don't round this off in your actual answer. You know, you'll see me writing 6.02, but I would keep extra decimal places in the calculation, so at the end I get a more precise answer. If you were to say the area was, you know, 144, that's totally wrong. 144 is not correct. It's not precise. It's definitely not full credit, maybe half credit. Because this 0.02, as you multiply by 24, it adds up to 4/10 of a square meter. Maybe that's important in some application. The last one here appears to be a parallelogram, but it's not. I want you to chop that, chop that diagonally there, and I'm going to shade in part of that. Now, as you shade this in on your paper, you'll see that shape is a triangle. The reason we're doing this is to show you how the area of a triangle relates to the original area. Kind of obvious that this is half of that whole area, which is why the formula for the area of a triangle has to do with the base and the height, but it's dividing that by 2, or taking half of it. So there's your 3 formulas you're going to be using on the homework today. And an example that goes with it here. Got a 20-degree angle, got an 8 on the bottom, 7 on this top side here. I think that's it. Give that one a try. Give it a pause and a try on that one. So hopefully you see on this, you've got the base, you're missing a height, 7's not useful. You could draw an altitude over here. Probably not as helpful as drawing an altitude here. There's always one altitude, generally speaking, that's better to draw than the others. And I'm going to kind of ignore this triangle and ignore the 8 for a moment, and just focus on that little right triangle there. You know you're trying to find the opposite side of the 20, which just happens to also be a sine ratio again. Simply focus on that triangle. Sine of 20 times 7, bingo, I get a height, which I'm showing it's 2.39, but I would keep all these decimals in my calculator. Keep that number in my calculator and hit times 8. And then, most important thing, do not forget to divide by 2. You're going to need double an answer every time, which is not going to work. If you got 18 on your paper or 19 on your paper, you forgot to divide it by 2. It should be around 9.6 units. Generally speaking, in this unit, I'm going to say round to the nearest tenth, which is 1 decimal place like I've done on these two. But before that, I'm keeping extra decimal places during my calculations. Hopefully that makes sense. Oh, there's my calculation in between. All right, one little idea, main idea, postulate on the bottom of your paper. Call this area addition postulate. It's going to be an example for you. It's a pretty simple concept. The idea is you can add up pieces of something to get a total area, as long as they're non-overlapping parts. So see if you can find the area of the shaded part of this. Create this little diagram on your paper. Got a bunch of dimensions on there. Yes, these are right angles here. Everywhere you see a right angle, this one I want you to assume is a right angle. That's a given that I'm giving you. I'll come back in the next part to reveal your correct answer.